working, keep practicing, and those kind of scenario. Sure, let's start. So, I'll start with just revision to mutability. So, can anybody tell me what do you mean by mutability in Python? Anybody? What have you?
Mutability means like you can change the existing structure, like the tuples, or less you can add and delete from the list. Whereas in tuples, you cannot do that. It's fixed.
Are immutable. Perfect. It's basically ability of objects to change their values, the content. Every variable is a container, right? So means when you create integer, when you create string, we do add values to that. Now, if we can change the value with the same address, then it's a mutable. If you can't, it's immutable. Immutability makes the object more efficient, more retrievable. Means the retrieval speed basically be in the multiples of the normal immutable is very efficient. It's the speed of retrieval and even deletion and all those things within the multiples of the normal immutable object. That's why we use mutable objects. This is for data throughput. We normally, as a data scientist, we play around with the terabyte, petabytes of data, and we need to churn out these data within minutes, right? Because we work on a data. We are data scientists. We work on data, their indexing, updation, push pull from database, and so on and so forth, right? In this scenario, we have to understand the throughput of data, and we need to basically understand the network bandwidth limitation. We need to understand the overall, cloud server limitations, and so on and so forth. So with all these things, the better you churn your data as far as compilation of code goes, the better your performance will be. That's why data churning speeds are really important in Python. So, and mutability questions get asked almost in every interview. So that's why mutability is important from job aspiration perspectives. Okay. So that's why I normally keep hammering on these things. We started with Python API, application programming interface. Okay. Here, what we're trying to do, basically get coupled with all the web servers of the world, all the web deployment of the world, and we use something called APIs, application programming interface. We try to couple our programming with the actual cloud servers, cloud deployment, the web servers of the world, the web services of the world, the microservices of the world, and so on and so forth. So these are needed for service-oriented architecture overall. We'll basically, learn about various architectural patterns. Service-oriented architect is architectural pattern, and we'll learn few today, and then we'll basically enhance our thought process in terms of building new solutions. Okay, and that's why we started with API. API is application programming. I think I already do application programming interface. Here, what we do, we request to the server. So what I'll ask, please get me a cup of, glass of water. Please get me tea. Please get me coffee. So like that, I put a request to a server, and server basically responds with a response code and response data. Now, response code is necessary because if he or she don't have these, they'll say, sorry, I don't have. Or he or she don't want to give, you say, no, you're not the right person to give this data. So all these response codes are necessary in terms of cloud, because talking about remote data transfers here. Then if everything is fine, I'll say a status code 200, and it'll basically also start sending the data. Now the data can be a single packet, like a number, integer, or data can be multiple packets. And on top of that, we have a streaming services. So first get request, response code. There are response code 100, 200, 300, 400, 500 in the range of these. And last time we have understood a bit of, those status code kind of descriptions. So one is informational, 100 is informational, 2 is success, 200 means it was successfully. Then we have a response code in between 200 to 299, which gives you in-depth, details of why can or can't send the info. Mostly can send the information. Then 3 is redirection. Means if I don't have the data, and if your authentication is successful, I might redirect you to some other server as well. It can be a subnet server in the sense we are a set of server who are basically supplying your needs, or which are servicing your need, to be precise in terms of IT nomenclature. So whenever you basically work with these redirections, these are kind of group of trusted server. So whenever you request something to a server, it'll either supply with your data. First of all, it'll give you a response code, which will make sure how does we interpret this response code. Response code is simple integer. It's a complete number from 1 to 5999. Okay, there are some numbers which are not used. There are some numbers which are used. We will see whenever we do some practice, right? And all these things basically make sure whatever I put a request to a server, get a response, and then there'll be a start of data stream, single data, multiple data structures, images, whatnot, right? So this is a step-by-step process. These are normally referred as HTTP status code. So if somebody asks you in interview, how do you talk to a cloud server as far as your program? So first and foremost step, you start with a HTTP request. That's a GET request. Then you'll receive a status code. If you are authorized enough, can you get authenticated yourself to retrieve that data? Then basically the next thing happens when you did that thing. If it says something like, I might need your user credential, the second thing, I'll send user credential. Once that's clear, I'll get a 200 code, and then I'll move forward in receiving the data step by step. HTTP header fields. Now there are something in normal cloud communications, we have something called headers, right? So what these headers do, these headers get transported with the data packed inside, so that I don't have to send multiple requests. If I'm sending couple of strings like a username, password, location code, IMEI code, or something like that sort, then I'll just basically send it with a single request. So my GET can encompass all these things as well. Depending upon the programming, depending upon the need of the hour, we basically build these architectural communications with the server from a client. Client means whoever is sending the request. Normally, client send a request to server. There are some things which style like smart clients and all those things where server also can initiate communications. And the same HTTP code basically gets validated by the client itself. So it's like mobile, right? You basically move around with your mobile. So I'm attached to a tower near my house as of now. But if in the night I decided to stroll out and I've gone to another, mobile antennas area and left mine, then the other mobile antenna says, "Hey, Ravindra, welcome. This number is now attached to my antenna," and mobile says, "Oh, thank you, thanks a lot." So that even your signal strength get boosted up because you are stepped out of the coverage of first and joined the second coverage. Now even that mobile server understand your mobile because he was constantly radio frequencing all the mobiles are basically kind of radio set, if you know. So these things get communicated and handed from client to server. So client send the response in some of the scenario, mostly in the mobile world, because server is active, client is a passive here. Normally, server is active and client is a passive. Sorry, here the active sends a signal to passive normally. And these things do change depending upon the scenario and possibilities. Nowadays, even Python, we have quite a good number of mobile developers. There, the HTTP status codes get sent from your mobile, and it's as simple as sending a string or sending couple of strings, as we discussed just now. Okay, so HTTP header is a kind of data request sent to the passive components by an active component. So rather than server client, you can talk in terms of active and passive entities. But normally, whenever you talks about cloud, so we attach to the cloud server to start with. So whenever I start my desktop, laptop, mobile, they first request to the server, okay, "Hey server, could we please get me registered?" Now I have signed in a Zoom server. So my desktop sent a request to USM server saying, "Hey Zoom server, I had a session planned." So that server will check with all his trusted buddy, did Ravindra Pandey have session requested? Have he planned earlier? Have any scheduler jobs for him? And so on and so forth. So after I get all those acknowledgements, they normally start the streaming. Nowadays, streaming is the most effective communication or continuous communication, continuous data transfer mechanism as we are utilizing right now. Or whenever we use something like Netflix, Amazon Prime, and all the digital TV channel services via web. So these are all clamped on the HTTP packet routing mechanism or HTTP protocols. HTTP is Hypertext Transfer Protocol. But then we are now at HTML5. You must remember this version HTML5 because in HTML5, rather it started with HTML3, we have started including the binary packets as well. So HTTP wraps everything. On the top, it looks like HTTP, that's text transfer, but internally we normally transfer binary also, like images, streaming, and so on and so forth. So here we are talking about encapsulation of a binary object over a text object. So let's try to understand the overall packaging of this HTTP. So we have a general headers. These header fields have general applicability for both request and response. A client request header. So client request header are specifically marked, or specifically these header fields have applicability only for a request message. And there is normally response expected, like server response header. These are named so even if the receiver is a client or a server, the name still stands. So server's response header, these headers fields have applicability only for a response messages. And the entity headers, these header fields define the meta information about the entity body, or no body is present about the resource identified by the request. Now, whenever you're transferring an image file, if the image file is bigger than a certain limit, depending on the limit set by the server, the web servers and the clients of the world, here what I do, I encapsulate the image or a binary in a text. In sometimes I just send the binary rather than encapsulating headers every time. This is also tried, and that's why we moved to HTTP5, where there could be barebone binary transferred over the HTTP. So you might change the name of HTTP to somebody else, but they'll still go ahead with the same name. If you want to read details about HTTP communication, please visit IEEE site, IEEE.org, IEEE.com. IEEE in the sense Institute of Electronics Engineers. Oh man, let me, I forgot the IEEE long form also, sorry. Anybody know IEEE? Anybody is member of IEEE? Anybody? No?
Not a member. I think it's Institute of Electrical and Electronics Engineers.
Yeah, perfect. Institute of. So you should visit this site. Let me show that site to you. This is a really important site, and this site maintains the standards overall. Okay. Oh, come on. Okay. This site, IEEE, Advanced Technology for Humanity. So this site is basically as ORG site. This site maintains the overall definitions or kind of standards overall, so that whenever you start something new, start any invention, you need to register with IEEE. Depending upon your invention, if it's a commercial, they will charge some fee. It's not a really heavy fee, but still you can register your patent. For all technical patents, they have a separate site, but they are connected with IEEE, and you normally talk about each and every communications via IEEE standards. So how much signal strength you require, how much distance you can have the wireless signal transferred, and all those things are normally given here. If you're an engineer by yourself, you can get registered. I think the membership is really not that much. You can join IEEE free as well, and I would really suggest you should, because you constantly get all these new email messages once in a week for about all new advancement in terms of new type of communication, enhanced in the older ways of communication, enhancement in the radio communications, enhancement in the modulated communication, enhancement in the web communications, and so on and so forth. So you can read those abstract, read those, even quite a good number of documents available here. So this must be your what you can say favorite site overall when you want to talk about the communications overall. Even the encryptions, we have great number of paper. Now when you want to secure your even HTTP communication, you encrypt it. There are levels of encryption: first level, second level, 3 level. Normally bank use 4 level encryption. So encrypted 1 level, encrypted another level on top of that, encrypted 3rd level on top of that, and encrypted 4th level on top of that. Right now, the payment card industry, PCI, works on triple disk encryption. If you want to have a look at that, you can search on a Google triple disk encryption, which is kind of also 4 level encryption. So like that, you encrypt your communication while doing these things, and you can learn all these about communications at IEEE. So if somebody asks you in interview who regulates the communications or who patents out the communication technologies, strategies, and all, so the answer is IEEE. It's not what you can say included in programming any scenario, but as an engineer we should know these things. So IEEE governs the communication mechanism, patents the communication mechanism, and if you try to communicate in any other way than registered, you'll normally get flagged as a hacker, or you'll get flagged as a anonymous request sender, and you might get blocked, you might get channeled to all auditory departments for such scenarios. So whenever you start communication, you have to go to some registered way to do that thing, or a normal adopted way to do that, right? So that's why we use HTTP status code. Let's take a step further. Please stop me when I'm going too technical, but this is a kind of need of the hour you should understand. And please do register with IEEE as an anonymous user. You don't have to pay anything to start with them, right? We had a look at video called Working with APIs Python last time. I'll just reviewing these things. So Python API, there is an amazing amount of data available on the web. Many web services like YouTube, GitHub make their data accessible to the third-party application through application programming interface. So you use any technology, be it R, C, a normal scripting like JavaScript, JScript, AngularScript, this script, that script, Ruby programming, and all that. They all use this API programming interface. API programming interface is kind of translator between client and server. One of the most popular ways to build API is the REST API, right? Architecture style. Python provides some great tools, not only to get data from REST APIs, but also to build your own Python REST API. So you can create your own APIs also. As I told you, there are some rules and regulations already marked by Python as a platform. So in Python, you can't go far and beyond after certain portability, but there are quite a good number of REST API libraries available. Like you have Spark, you have quite a few basically, but we'll just go with the inherent library from Python, which included in Python for the REST, and we'll first try with that. Okay, the REST stands for representational state transfer, and it's a software architecture style that defines a pattern for a client-server communication over a network. So this is a standardized extension of HTTP. Wherever we start with the basic API as far as Python goes. REST provides a set of constraints for software architecture to promote performance, scalability, simplicity, reliability in the system. Okay, we had a look at working with API platform, and I'm sure you might have a look at it afterwards. If you have still any doubt, please have a look at working with API platform again. I'll share the link again. Okay, it's a long video, so I'll not play it again. Today we'll basically venture into how do you program it out, right? So let's go ahead and take a deep dive into REST API, representational state transfer application programming interface. Is used as HTTP request for communications with web services predominantly. So we use something called SOS. S for service oriented architecture. It's comply with a certain constraint. Here are some of them. Client server architecture. The client is responsible for the user interface and the server is responsible for the backend data storage. These are standardized mechanism. As I told you, there could be a scenario. You might be a server and others might be a client. And I have just given you an example. But in almost 80% plus, we are the client. Client and server are independent and each of them can be replaced. Okay, even we can replace server, we can replace even server can replace us. Stateless. No, so how does server replace us? If anyone else came into our mobile server, his mobile can be act as a new active client. So the client, the server serving client numbers gets increased by one, decreased by one, depending upon the mobility of your cell phones or the radio sets, what you can call it in a technical scenario. No data from the client is stored on a server side, but this is again a kind of ground rule which is normally updated whenever there's a need for so. The session state is stored on the client side. If you know, we normally discussed about the session variable. Session variable is a key assigned to each client whenever he initiate a communication. Now this session key is important. Session key is also labeled across platforms. So if you work with C, R, Python or any other platform, it's still called a session key. So session key is a 32-bit alphanumeric key assigned to a client whenever he or she, whenever client initiate communication. Clients can cache server response for improved performance. Now, how do you cache server responses? In cookies, in any other normally text saving mechanism? But now, whenever you talk about something like as complicated as encrypted communication, we might save some binary responses also. These responses are basically can be something like a QR code or an encrypted image which is saved on a client side. So whenever next time you start or initiate a communication, you might start from the previous session handle, and it depends on the timeouts and everything as well. But in case of streaming, as we are continuously streaming or continuously accepting the server binary data, we might need to validate that binary data with a key, right? Or decrypt the data with a key. How do you do that? So you have some binary cache stored on the client. So whenever you look at a streaming video service, normally there's a binary decryption key gets activated each time a data packets come to you. And this is how the overall movie decode works on your mobile from the server packets, right? So even if server is sending these packets, it's not easy unless and until you have the specific key to decode that packet, or you can't read the communication unless and until you are authorized for. Does that make sense, or I'm complicating things for you?
No, we're good.
Okay, so you're understanding what I'm trying to say. Good. That's really good. Let's try to understand a kind of states or couple of technical terminology within this Python REST architecture. So there are stateless. The server won't maintain any state between requests from a client. So the responsibility of maintaining state. So whenever I disconnected communication last time, which server I was connected previously in specific IP address way. I believe everybody knows something like IP address, right? Anybody who don't understand what you mean by IP address? Okay, so we got IP address is a number given to any computer which gets or any processor with RAM and some calculative power whenever it's get attached to the internet, right? And so on and so forth. So this IP address is basically acts as an identification of a typical client. Now IP address get clubbed with your MAC address also. In case of mobile, you have something called IMEA. IMEA is a key handled or basically get initiated with your mobile OS, mobile processor ID, and the basic mobile tower server location. And this IMEA key is basically first level encryption as far as your mobile communication goes. You don't have to remember these things. I'm just sharing with you because we should know what you mean by state. Now, this state of communication is basically encrypted, enabled, or registered. This state is normally maintained by the client. So normally, whenever somebody asks who maintained the state in the REST architecture, the client maintained the state. The client and server must be decoupled from each other, allowing each to develop independently. Now there are some updates for client or a server, and they get done independently. The communication is not continuous communication. These are normally request response data, request response data. So these kind of packets get communicated across the wireless mechanism. Normally it's a wireless mechanism. Few times, like desktop, we are which are stationary processor based intelligent machines, they are connected with wires. But normally all these REST architecture happens over Wi-Fi. Does it matter? No, because we are using something called standard HTTP protocols. Okay, so protocols is basically a pipe which gets connected. If you start communicating with wireless, Wi-Fi, or wired communication. Okay, now cacheable. The data retrieved from the server should be cached either by the client or by the server, depending upon your efficiency required in communication, depending upon your solution architectural patterns, and so on and so forth. We normally define or design the solution that way that whenever there is a need, the data get cached on either side. Uniform interface. The server will provide an uniform interface for accessing resource without defining their presentations. Now every server, and this is included in the server operating system, that the server has a standard opening gates, and that's what we call ports. So whenever a mobile gets connected or gets hooked up with a mobile tower, the mobile intelligently know which ports the request should be sent and which port you normally have if you are doing an audio call, if you are doing a HTTP call, if you are doing a video call, which type of ports and what type of data bandwidth he or she, the client is allowed to use. And we normally have a caps of maximum and minimum bandwidths for each and every server. So even server communication is defined in a standard way. So whatever server you erect, it can be Windows server, Unix server, Linux server, or even if you have your own server, you have to follow certain communication standards. These are also mentioned in the IEEE website. Or there are some HTTP organization body like W3. They also have some regulations as far as the server lookouts or server ports communication goes. Now these gates are normally called as a port and they are denoted by a number. Just to give an example, 8080 is a standard HTTP port for a client. For the client, in the sense, if you are receiving something on your web browser, your client can act as a server because it's receiving packets continuously, right? Now these server and client names are, again, server is supposed to be serving, client supposed to be receiving. So whenever you are receiving like a movie from Amazon or a Netflix or YouTube, frankly speaking, right? So that time your client means your mobile, your desktop, your laptop can act as a server because he is continuously receiving the streaming and serving the data request to the actual cloud server, the YouTube server, the Netflix server, and the Amazon server of the world. So that's why these labels can get interchanged within the communication as well. And our HTTP protocol, HTTP5, is enabled enough to understand who is a server, who is a client, and who is serving whom at a certain point of the day. And so the session variables get interchanged, or the same session variable can be labeled accordingly depending upon the communication happening actually. Okay, so doesn't think or do not restrict your communication. Like whenever you request, you are the client always. You can be a server, And there are some details which are shared from your side to the server as well. And then there's something called layer interface. Now, what is layered interface? You might be connected to the internet via some internet service providers. Like I'm using, MCNL, that is Bruhan Mumbai, Bruhan Mumbai telephone services. Now I'm connected to internet via telephone lines. I have an optical fiber network, but independent of what type of connections you have, you normally have an ISP. Now this ISP might have thousands of clients like me, which are being served as an internet client, right? Now here, whenever I connect to a Zoom server in US, the Zoom server is not bothered with these ground scenario. It just create a HTTP pipe, which is independent of the routing mechanism. And that's how we have improved our HTTP communication. So what we do normally, once you get connected, the Zoom server will give me a session ID, and then this session started, like we are connected now. So even if the internet get disconnected, I might switch to mobile network. And whenever I joined Zoom again with the mobile network, the Zoom server understand, okay, Ravindra Pandey was disconnected 3 minutes ago, and that was the session ID last time. Whenever he disconnected, he was connected through some another route, but now the routing has been changed, but the packet or the streaming or the pipe still has to be maintained because last session have not closed. So it also allocate the same session, might be with a new session ID to me, and the session continues. So these things do happen in really advanced way. There are many things shared across as far as Zoom server and my desktop is considered, and either could be server or requester in either point of time. Okay, so this way, and the technicality of this happens like the client may access the resource on the server indirectly to other layers such as proxy or load balancer. Now this is because when I start connecting, I might connect with the mobile network, and then I might join with the optical fiber network. This thing can happen, but still the server and client know what were the requests and how I am serving them. So those kind of scenario. REST is not a specification, but is a set of guidelines on how the architect a network connected to a software system. So we are basically thinking like two intelligent terminals connected via this HTTP pipe, just to be simple. Hope you can understand what I'm trying to say. So whenever somebody asks you how REST works, so two intelligent systems connected via HTTP pipe. Is it clear to you? When you explain, you should be independent of all these stateless, client server, cacheable, uniform, layered, and blah 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 things. It's as simple as two intelligent systems, processor, RAM, storage. These are the intelligent systems connected with each other via HTTP pipe. Could you say these things? Have you understood what I'm trying to say?
Yeah.
Yeah, but if anybody goes into depth of asking, tell me about the statelessness, tell me about the client server, tell me about the caching thing, you have to explain the few other things as well. Okay, because those are the specific questions. If you want to go in depth into HTTP communications, you can ask the specific question, and I'm happy to answer those things. I have worked on something called socket programming. Now I'll tell you about the socket programming because the point just popped up. Socket programming is a low-level programming in terms of network communication. If you know OSI 7 layers, have you heard of OSI 7-layer architecture? Anybody? Oh man, okay, no problem. I don't want to go into technicality because then we'll get diverted from the overall Python programming. Just to give a quick idea, every operating system have a digital communication mechanism inbuilt to it. And these are normally C structure at the lowest level. So even if you want to communicate via assembly, you can. Low level C, you can. Now these are done with the C structure transfer, a basic C structure with integer, string, boolean, and these type of structure element get transferred across. That's how it started. Now in 7 layers, OSI have 7 distinct layer. Every operating system have 7 distinct layer of the way operating system is programmed. And there's a standard way of development of any operating system. So if you recompile any Linux, which is freely available with your name, I can have Ravindra Linux. And you can try sometimes. It's not as easy as talk. It almost requires a year plus efforts to understand the standardized OS and then get registered and blah, blah, blah things. But still overall, you have to have these standardized 7 layers, and those are called OSI 7 layer. OSI, operating system interface, 7 layer. You can search on a Google and you'll get all these details. These are standardized way of building network communications. And this is how started in late 70s, that is 1970s, of how computers can talk to each other. So previously it was just a wired communication. In 80s, we actually started working on wireless communication, which get matured in late 80s or early 90s or mid 90s, the way you want to say it. But in mid 90s, we also started on extensively on wireless communication, and we basically even started parallelly using something called many networks connected with each other, and that's what the internet is all about. And that's why we have a what you can say layered system. This layered system, you have a client attached to a server, server attached to another server, server attached to another server, and that way we are connected throughout the world. And this is what we call internet at its center, internet backbone. It's a logical server family. So once you connected to the server system, that is internet, you normally get issued a IP address. And that's why IP address is your identity till you're connected with the internet. And there is something called dynamic IP and static IP. Bigger system, they use something called static IP. The smaller system like your mobile and all, they use something called dynamic IP. Now this IP address is distributed with the standardization of a OSI layer to each and every intelligent terminal. Now, okay, the terminal and server, when we basically moved to HTTP5, this terminal and server got blurred. So a terminal can act server and server can act terminal. That's how we can say it's a stateless. So we don't normally maintain these labels, but we still maintain the HTTP pipe, and one can speak, the other can speak as well. And this is what we call two-way communication. There are types of communication, and this is the kind of two-way communications we are working on, right? So here, these are basically something called REST. These are not specification, these are set of guidelines or set of programming rules which are created to make sure whenever you start your communication or when you start using HTTP, there are basically some REST protocols, REST rules to be followed. Protocols means rules. Protocols we call it because this is a digital communication. Normally, rules we are used in a human communication way. Now these are digital communication, intelligent communication. That's why we use some word called protocols. And protocols are channeled through certain gates. Now the gates are called ports. These ports are a standardized way to communicate with a server or a client or start initiation. For that we use HTTP port, right? Now let's have a look at this video where we're going to learn how we implement these things in programming. Keep learning, learning ahead and ahead, right? So we had to look at API. REST web services and web services are adheres to the REST architectures. The web services export their data to the outside world through API. REST API provide access to the web service data through public URLs, right? For example, the GitHub, GitHub, right? GitHub is an online source control mechanism. It started as online source control, but now it's really a big, knowledge base, and you can have all the great, what you can say, great programming samples available on a GitHub. Let me show you GitHub. Now, just to make sure, oh, come on. Oh, I've not signed it. I should have, okay. Let me, okay. Let me share the GitHub, this thing with you. When you normally give github.com, you get here, right? You can see, this will be the one of the most important URL we are going to use as a data scientist or as an overall, trying to showcase our programming capabilities, right? And you will also get registered here. It's as simple as, it's open system. You can register freely and create your login ID. I have my own login ID. I am just signing into that. Okay, so this is my page. I have, a couple of things enabled here. So Python, data science, machine learning, and all those things. You can also create as many repository as you want, and so on and so forth. You can have a pull request. You can have issues logged here. There's a marketplace here. So in marketplace, you have all these, Circle, CI, image bot, and all these type of code available for you to try. So you can go to image bot. This is a, app for optimizing your image. If I want to use that, I'll click here and it will take me to the repository. I have to set up a free trial because this community want to get notified if somebody wants to use your code. Now, what are they doing? They're, sharing us these, 4-5 images, and they given the REST API code for that as well. So once you subscribe to them, they'll give you the Python code because I have registered here as a Python developer, Python data scientist. Okay, then there are, documentation links and everything available here. So please do register for the GitHub. There are lots and lots of, community here available. You can have a look at it. So you don't have to type your code to be precise. You can just copy paste and start using this. There's a special, code available for Spider as well. What's that? The Spider can directly get connected to GitHub. So, oh man, I have already connected. I can't show you again. But yeah, let me show you that YouTube link where, they tell you how to get connected with Spider. I couldn't see. These things keep changing day in, day out. So if there's a new popular code, they'll put it over here. So this is according to the popularity rather than the check-ins or checkout, right? And there are various topics also. If you want to have a development in particular topic, you can go to these. These are the ID one because I was checking for the Spider, but I can see, Spider integration here. Setup atom GCC, mini GW, man. There's new Atomic Studio for C. Wow. C guys are picking up on AI, I believe. Well, GitHub is overall, a really big, source library, you can say. And you should have your own as well. So if I say, let me, SPYDR. So let me check out if I can find Spider one. No, I can't find Spider. Oh, come on. Okay. But I have, and they might have been updating these things, I believe. That's why, something wrong. They might be updating the server because it's in a night in North American region. This is in this is near, I think they have their server farm near Chicago or something. So their central time works. So they might have some time down or something. That's why. But yeah, these guys are not really big on spreading out the message for maintenance and all. If you have registered, you might get an email saying we are maintaining our server. So it might be updated on so and so day and so time, so on and so forth. So this is a GitHub. Please do subscribe to this. You can start a project and all those things will I'll tell you how to start a project, how to get connected and all. But just get started with the registration first. Try to play around with. Try to find out if you can find any source code which you want to try and all those things, right? Let me try again. Skink. Okay, yeah, I tried last time Skink one for the last this thing, pixel art, full assistant. Okay. Can't have Okay, so I don't want to keep trying on these things. So yes, there are various technology. I am subscribed to Raspberry Pi also. I work on Raspberry Pi as well. So those are also will come out here. So I have these IEEE things going on in parallel. So not problem. So that's all. So please get registered with the API. Sorry, please get registered with GitHub. Start those weekly one email kind of scenario. I think you're intelligent to get registered freely. You don't have to pay anything. So it's really good. This URL allows to access information specific GitHub user. You access data from a REST API by sending HTTP request to a specific URL and waiting for the response. Okay, there are some standard HTTP methods available. A REST API listen for HTTP methods like get, post, delete to know which operation to perform on the web services resources. So you allocate resource to a web service. So if you have given an access to a client, you can restrict the access to a particular table, to a particular row, or to a set of rows as well. So you can restrict the client access to a volume level, to a database entity level, to a request level as well, right? And so the response will get configured accordingly. A resource is any data available in the web service that can be accessed, manipulated, in the sense updated with the HTTP request. To the REST API, the HTTP method tells API which action to perform on the resource. While there are many HTTP methods, the 5 methods are mostly commonly used. So these are like get, the first, the post, put. Get is retrieving an existing resource, post is create new resource, put is update an existing resource, patch partially update an existing resource, patch is like update, delete is like delete a resource. A REST API client application can use these 5 HTTP methods to manage the state of the resources in the web service. So state is basically the HTTP methods you are processing for the particular API. Okay, then just to go ahead, there's something called SOAP, Simple Object Access Protocol. This is like before REST, we were using SOAP. So SOAP is a kind of XML pre-configured request over HTTP. Now there are many such architectural communication mechanism available. REST is the most efficient. SOAP talks about the object access protocol. Now SOAP is basically created for binary communication. As you know, objects are normally binary objects, right? Otherwise we can just say string, or we can say variable normally. So object is basically a complex variable with a combination of simple variables, right? So here what we are talking about are typically associated with the enterprise world, or a kind of developed communication mechanism, has a stricter contract based usage and mostly designed around action. Now SOAP has many structural challenges in terms of whenever you are giving access to a client, it's more disciplined than REST. REST is quite generic and standard. SOAP is more restrictive and mostly it's a well-structured communication rather than generic as in REST. So SOAP is basically used for more defined communication, but SOAP, as you can understand, it's a bundled communication. So the data transfer speed required in SOAP at a higher pace than REST. I'm just trying to share the ideas of from my previous experiences, but nobody will ask you a question like compare SOAP versus REST. Okay, even though some of the examples mentioned above are graded towards newer platforms for apps, web APIs have been around for quite long time. In late 1990s or early 2000, two different design models become norm for exposing data publicly, SOAP as well as REST. Nowadays, SOAP is used not that frequently because HTML5 is more tuned with the REST type of communication. And in REST, we try to use maximum text or binary object wrapped around text. Yes, binary object wrapped around with the text. And that's why REST is more, what you can say, more frequently used than SOAP. There are some client server mechanisms still use SOAP. SOAP is kind of XML based communication. So we'll more concentrate on the REST type of communications as far as Python goes. Okay, now JSON. JSON is a kind of a step ahead in REST. Basically, JSON is a JavaScript object notation. Now, whenever you do communicate binary, there has to have standard communication mechanism, because we shouldn't let it go the efficiency of a text communication. And that's why JSON is the kind of medium which scientists have developed just to make sure the HTTP won't get loaded with the binary objects. I hope you understand what I'm trying to say here, because I'm sharing all the great details of communication with you today. Any confusion in understanding JSON as of right now, or any difficulty in understanding why binary, why text, or how text wrap binary and all those things? Could you understand what I'm trying to say here?
Yeah, we can get it.
And I'll give you, okay, I started the recording. Let me check out. Yeah, so please do listen to this recording again, because I'm sharing the details from my overall 28 years of experience. So it shouldn't happen that I go too deep into technicality, but at the end of the day, as a scientist, right, we should know the underlying idea of it. Even if you know to practice it day in, day out, but you should know the idea, how and why we are doing this, right? So JSON is a kind of step ahead for binary communication on REST API type of communication. So predominantly what we are trying to do, we are trying to achieve the text transfer speed with the binaries. So here a full form of JSON is JavaScript object notation. JavaScript is one of the most simplest scripting language programmed on the net. Is as simple as connect to Ravindra. So it will connect to ravindra.com, something like that. It's as simple as we speak. If you want, I can tell you, I can share you a couple of JavaScript video as well. It's really pretty simple. Okay, so that's why what they say, JavaScript have an object notation. So whenever you create a binary object in JavaScript, specifically image, when you transfer image via scripting language, it's a plain simple unencrypted communication here, right? It's like, whenever you want to say a dog image, you don't want to encrypt it, right? It's a dog. Even if somebody, hacks it, let it, no problem for me. So that type of communication we are talking about. So these are non-secure object transfer, which are fast and efficient for transferring from client to server or server to client. It means that script or the executable file, which is made of text in a programming language. Scripting is a text programming, right? Is used to store the and transfer data. Scripting is predominantly text transfer. Python gets compiled, C gets compiled, R gets compiled, but script get executed directly as is. So the commands are visible even if you send a request via HTTP. Is used to store and transfer data. Python supports JSON through a built-in package called JSON. Simple enough, no problem, right? Because it's just a text transfer. So you're just transferring a command via a variable. As simple as that. There's no encryption and all those things. To use this feature, we import a JSON package in a Python script. The text in a JSON is done through a quoted string. A simple string contains key value mapping with what is curly brace, dictionary, tuple, list, set. What is curly brace?
Dictionary.
Perfect. Yes. So we are sending a dictionary of key value mechanism to process this text-based command directly over HTTP. We are not binary-fying it, right? So it's just wrapped around with something called JavaScript object notification. That's why it's called JSON. I haven't, there was, I think, 1 or 2 interview where he asked what is JSON, but normally this question is also quite technical as far as data scientist way of communication goes. In those interviews, they were trying to basically improve their web communications. They were having problem with channeling data via different web server. So they were specifically a kind of web data communication improver type of data scientist job. So that's why they were asking this question, like, tell me about the JSON as in communication. So you need to tell them this paragraph. Reading JSON, it's pretty easy to load JSON. As simple as it's a text bundled in a string, right? It's called JSON, which can be used to work with JSON data. It's done using the JSON module. which provides with a lot of methods among like loads. Loads is like multiple loading, load is just one pair, and so on and so forth. Okay, deserialization of a JSON. HTTP is not a serial communication. Okay, serial communication is like I'm speaking in a sequence. So if you take my sentence out of context, it doesn't mean anything in life, right? So for that, there are some communication which are serialized and some are deserialized. In deserialized communications, you normally always transfer reference as well. So this is statement number 344. So you have to play this after 343, and unless and until you play 344, you couldn't understand 345. So something like that sort. So deserialization is basically you are passing reference with each and every communication. The deserialization of a JSON means conversion of JSON objects into their respective Python object, the sequence of it, right? The load or loads method is used for it. So load and loads method carry a sequence number, to be precise, with them. If you have JSON data from another program or obtained as a string format of JSON, then it can be easily deserialized. So Python has inbuilt mechanism for serialization as well as deserialization. Normally, it's a serialized object load or loads, but sometimes we might use deserialized because in case if the communication is broken, we shouldn't have to start from start. So whenever you have a deserialized, even if the dependency on the communication channel or mechanism is not there. So that's why we normally use deserialized mechanism on APIs or on JSON, to be precise, whenever you're doing this JSON programming using Python. Okay, we'll practice just after file transaction. We have a complete programming of files after these architectural patterns, and then we'll move to actual JSON programming, and we'll try to do a smallest possible program rather than the guy who did with the web server and all Flora and Bonafide. We are data scientists, so we'll start programming with the least programming lines. Does that make sense for you? Or you want to be a Python programmer? Please guide me and I'll help you. So does that make sense, sir, madam?
Yeah.
Yes.
And if you have any question, please ask. Means don't hold on yourself. Like I'll ask afterwards and all. Okay. I believe this is a kind of more of a theoretical in this session and next session, and then we'll actually go into the actual programming of those things. Okay. But these topics do matter a lot from interview perspective. So for bagging a job, for acquiring a job, for clearing an interview, these sessions are really important, because nowadays whatever you do through cloud, right? We are going to do develop solutions on cloud only. So that's why understanding JSON is a need of the hour. And nowadays even we work remotely, so for that matter JSON does create a larger impact on our day-to-day development. Nowadays all data scientists, they have given a specific server farm. Now server farm is basically a cloud ID where you have multiple virtual servers. So whatever you develop on those servers rather than hitting the actual commercial server or freely available server. You might have given a typical server farm specifically with Google, Amazon, or any web services or any cloud service provider available in your region, specifically depending upon North America, Canada, and there are a few favorites of every organization as well. So if you normally go with Patni, if you go with Infosys, they are well tied up with Google. If you go to Cognizant, Wipro, they are well tied up with Microsoft. So depending upon the company you work with, you normally get these cloud servers at your disposal to programming, or to basically generate solution, as we call it, as a data scientist. Okay, I believe I have not confused you more, but let's take a step further. We use something called Graphql as well. Now, after JSON, Google and Apache Foundation came together and then say, we want to enhance the Google Earth project. Have you heard of Google Earth by any chance? Google Earth?
Yeah, Google Earth.
Okay. This was really famous in late 90s or early 90s or late 90s. It was the first AI type of program Google have developed based on map object. Now, what is map? See, wherever I stay, I should know the locality, right? So I stay at Kanzuma near IIT Mumbai. If you know, uh, I have to know what is around me in case of hotels, hospitals, ATM, this, that, other, right? So for that, we use maps. Means even before internet, we used to use map in a paper. Now use map on a mobile, on a desktop. Google started that overall understanding these things in late 70s with Google Earth. So they started basically with North American map. They started with a typical LiDAR type of camera. LiDAR is laser activated panoramic video inceptor. So there are laser guns span over the terrain, and it basically notes down the hill, the pits and gaddas, the roads, the forest, and the reservoirs, water, and all those things while the plane moves over that terrain, right? So they started building this Google Earth in late 70s or early 80s, and by late 80s they had a really big amount of database with them, so that all North American terrains was covered. Now what they do, they created something called Google Earth to connect all these maps together to form actual 3D digital terrain in the computer memory. And this was kind of a big trigger for AI to start with, because how to connect which tile where and all those things has to do a digital point mapping by the server or by the actual computer, the intelligence system, right? So that way they started building AI beyond these tiles connection mechanism. They were used to call it tiles then, and we call it tiles even today as well. So if you look at Google Map, it's a kind of small tiles connected together with the artificial intelligence mechanism. Now we have a query language developed for these tiles database or digital map, what we call, right? And it's called Graphql. Now there are quite a few good number of enhancement goes into this GraphQL. Nowadays we are working on something called driverless cars. Like, everybody heard of driverless car? The automated car, automated driving, and all those things.
Yes.
Yeah. So there are quite a few new job openings in this driverless car type of technology, and that's why GraphQL is really important to understand as far as data scientists are concerned. So that's why I've included these things. And there are specific GraphQL as in query language, and specific API for this GraphQL as well, where we normally try to understand the map mechanism, the pointers around it, or the active elements around a given tile. That's how they call it. Okay, so for that we have good number of projects available on GitHub also, and Shopify as well. Shopify is another web company who work closely. They were started as a small group where they want to basically maintain information about tile in terms of ATM, hotels, construction, more of a real time rather than a pre-programmed tile connection mechanism. So they have added a layer above the tiles database saying the active entities on a given tile, and so on and so forth. So that's how these things club together with Apache Foundation. So GraphQL or MapDB is the actual DB, which is available open system, means Google have made it open, not the latest version, the previous stable versions to you, where you can actually put a Python query on the GraphQL and have Shopify also imported to your programming mechanism, and try to find a tree, a broken signal, or a road construction at a given point as well, or at a given location. So that's why GraphQL is really important. I have included this thing just to make sure we understand the relevance of it. This is one of the most data scientific open system example available there, which don't require too many mathematical calculation. So if anybody want to go to a data scientist cadre which is not so mathematical, GraphQL or Matplot is one of the most important or well-paying job available for a data scientist as far as non-mathematical data scientist goes. Does that make sense, sir, madam?
Yeah.
I'm just thinking loud here, or basically trying to share, because this question was asked in last to last batch by one of the lady who was working at a Boston municipality, and she was basically venturing into data scientist. She was really good, frankly speaking, in terms of programming. She had work on COBOL and all those things. Now she was venturing into Python. She asked me a specific question directly. Tell me a data scientist job which don't use maths too much. So this is the job, or this is the data scientist cadre. And there are lots and lots of jobs available, because there are, I think, around 20, 21 odd organizations, big multinationals, who work on these MapQuest, MapDB, GraphQL type of projects. Okay, and these are mostly more of imaginative, or more of, if you know isometric drawing, if you heard of isometric drawing, these are more of imaginative drawing type of stuff, because you need to understand the terrain and connecting tile or the adjacent tile to the given tile, right? And that's more of imagination rather than a calculation. So you need to fit the point. So it's like pair matching rather than mathematical. Well, it's also difficult. I'm not saying it's a cakewalk, but yes, it's non-mathematical rather than mathematical programming. So there are some jobs available as far as non-mathematical. Otherwise, we have all statistician and programmatical job available as far as data scientist goes. But this cadre, they use the least possible maths. Okay, so yeah. Oh man, it's almost 10:30, right? Oh, pardon me. Okay, so let me wind up here today. In next sessions, we'll learn architectural pattern. There are around 10 most commonly used architectural patterns, which we will work with. We have MVC, we have peer-to-peer, broker, and all those things. These are required basically just to understand how the design pattern or architecture pattern have chose, even in terms of Python or in any other language for that matters. There are many questions asked in interview. That's why I kept this session specifically for patterns, just to make sure if there's any question on pattern, what to answer and how to answer, and those kind of scenario. I have also included microservices, service-oriented architecture, and then we basically will start practicing on this REST API and different patterns, plus the database programming and all those things. Okay, so that's it. Yeah, that's it for the today. Do you have any questions for me at this moment?
No, we are good, Ravindra. Yeah.
Okay, sure. And pardon me for too much theory, but it's a kind of need of the hour. Unless and until we know these things, we can't implement in our programming, right? So that's why it's a need of the hour, and that's why I had to take a couple of these theoretical class as well. And then we'll basically get hands-on again. Okay, so next class is on architecture patterns. Thanks a lot for your time. Let's see you day after tomorrow. Have a good night. Bye-bye. Take care.
Thank you.